So Merck Sharp and Dome is a facility in Carlow. They make vials and syringes. I have to admit, I know very little about vaccines other than the couple that were stuck in my shoulder a couple of months back, and they're keeping me safe and well. But the site has grown significantly over the last 10 to 15 years, from 200 people, and there's currently about 1,200 people working on the facility. The little project I was working on way back when was item 9 on the screen there, which was a quality operations lab that was being built. It's a grade D laboratory that was being installed. And there's other developments that have since occurred, including Building 10, and there's another building currently going through the design phase. So they're building a third manufacturing facility there as we speak. The facility itself uses 36 gigawatt hours per year worth of energy, so it's by no means a small facility, and there's 50 million units of output coming from the plant. So this is the Quality Operations Lab. The project itself cost €25 million, so just over 2,300 metres squared of floor area. We wanted to get LEED Silver, and here's where I started to have a few little issues. We're already going for LEED. What's this EXEED thing? And why do we want another certificate? But the design team, or sorry, the operations team on site wanted to figure out how this energy efficient design that was being proposed by SEAI would fit within the Merck Sharp and Dome operations. So we got into the project brief that we wanted to get EXEED designed as well. So that became a deliverable of the design team from the outset. So I guess there's a lovely front of house in the laboratory area. There's just a few images here of the lab as it's finished. But during the design phase, we were looking at drawings and trying to figure out what this was going to look like. But the majority of our time and effort was spent back of house in the plant room with the purified water skids, the air handling units, and psychometric charts, and why are we doing things the way we currently are? When are we using the energy? Why are we using the energy? And a lot of the discussions were happening around the back of house plant room. In order to put focus in the right area, the first thing we have to do from an EXEED point of view is develop an energy balance. The diagram here on the left-hand side, the energy balance, was developed using an IES model, where we simulated the amount of energy that was going to be used in the facility so that we could then move on to the challenge and analyze phase. There's no point in spending half of your time challenging lighting if lighting is only 2 or 3% of the energy. So what we had to do first was figure out light, heating, ventilation, air conditioning was going to be the biggest energy user in the laboratory. So therefore, most of our time was spent talking about heating, ventilation, and air conditioning. We didn't spend a whole pile of time thinking about lighting because that was a relatively small user. And lots of design teams believe, if you read a concept design report, lots of design teams will have the sustainability element is about IE4 motors and LED lights and we're finished. Well, actually, from an EXEED point of view, we spend most of our time talking about where the majority of energy is being used and challenging design teams as to why we need the air changes, where we need them, do we need that grade of energy or that grade of clean room in that space, or could we run with an unclassified space rather than a grade D? Out of the challenge and analyze, and so for example on the ventilation, as Jason mentioned, you start with the energy service. Why do we need the ventilation in that space in the first place? When do we need it? For how long? Can we is there an opportunity where we can turn off the ventilation or set it back? Rather than the typical, it's on 24/7 in pharmaceutical plants. We looked at the process and we looked at Phoenix control dampers to be installed instead of just manual dampers. The equipment that was serving the space, the controls, including the fume cupboards and how the fume cupboards would operate, there were opportunities around that we were able to build in. And then thinking about operations and maintenance and management. There's the list of opportunities on the right-hand side there. There was 56 opportunities identified. About 20 of them got in. So this is a bit like a Santee list. You get all of the ideas onto the opportunities register, and maybe half of them you get in. The earlier you have the discussion, the more of them you can get into the design. But the later you start the discussions, the harder it is to try and implement any change, especially when design teams have drawings finished or sequence of operations already signed off, trying to make changes to those diagrams and the way things work is really difficult after the fact. So it's very easy when something is in draft to make changes from a design perspective. So my first meeting was developing this project execution plan. Why are we here? What do you want? We're the design team, we know what we're doing. So we sat down with the design team to explain the roles and responsibilities, the energy efficient design objectives that we were looking to achieve. There was a little piece of training. What's this EED expert? And the reason I don't like EED expert is that you're the person standing on a platform for everybody to throw stones at you and to demonstrate that you don't know as much as the design team. So it's actually trying to facilitate a discussion. Let's spend a small amount of time designing the system from an energy point of view, not just for function and for quality, but we spend a little bit of time thinking about sustainability as well. So we outlined the roles and responsibilities, schedule design team meetings during the design. This is not, I'll take the concept report at the end and review it to see if it's okay. This is having active input into the various reports. And inclusion in a number of documentation reviews, where we have a little bit of engagement throughout the process. From an energy balance, I talked about it earlier. We have LEED and EXEED requirements, so we got an IES model developed against ASHRAE 90.1. So that served as an energy balance from an energy efficient design point of view. It also served as the energy balance from a LEED perspective. So it was the same model rather than having two different models. It indicated HVAC was the largest user, and we went through what I said there with the challenge and analyze piece on it. The Venn diagram is, as Jason said, the core of it. And slowing down and asking the questions, why do we need it? Where do we need it? How long do we need it for? Is this the best technology that we need? And just as an example, not on this project, but on another, where we've got a steam system providing heat for a ventilated space. Why do we need steam for heating that? Surely we can put a hot water system served by a heat pump which serves future decarbonisation needs. So as part of the challenge and analyse, we need to ask some of those fundamental questions as to why we're doing things the way we currently are. There's a whole load of ideas in there, opportunities for improvement that were identified. As I said, about half of them actually got implemented. The other half, they were either too late or the organisation were risk averse and didn't want to implement them. But the aim of the design challenge is to actually get all of these ideas out on the table and discuss them rather than just, oh yeah, sure, there's no point in thinking or talking about that. So design for energy management is an area that's typically not taught through too well from a design point of view. So this is thinking about how the plant will actually operate after the fact and building the design or the maintenance routines into the PM schedules of the facility, the types of alarms that will actually occur. And one of my mantras inside in pharmaceuticals is telling pharma, I don't care about quality, because everybody else in the room cares about quality. They're all focused on making sure that the GMP space is correct and that it's alarmed to the hilt. I want to know if the chiller is running when it's 2 degrees outside. That's the kind of alarm I want. Or if it's very hot outside, that we're putting a load of LPHW into the building. So I want to be able to know and investigate if those things are wrong. So we want to think, how will I know when the plant is operating efficiently? And how can I get this to alarm when the plant isn't operating efficiently? A metering system is key to a lot of this. For this site, this was integrated into the site's ISO 50001 management system, so it's monitoring on an ongoing basis. Some of the lessons I've learned, I won't keep you too much longer. So we needed to sell the benefits of this. It's a 29 million euro or 25 million euro project. What's in it for Merck Sharp and Dome? And what's in it for the design team? Well, we had to explain the benefits of doing this and demonstrating that the design team were going to deliver a good, efficient design. That's what's in it for them. Start the process as early as you can. Ideally, before you start optioneering. Start with what do we want to get from this project and writing down energy efficient design objectives. Don't mix up energy efficient design with the EXEED grant. They're two separate processes. There's a grant that's required, but the EED process can happen whether you're building your house, designing a route for Dublin bus, or building a large pharmaceutical plant. So the energy efficient design is challenging and analysing why we're doing something or why we're using the energy when we're developing the process itself. The certification process is a good tool because then I can blame somebody else and say, it's not me, it's actually those certification bodies that are going to ask for this. So can you please give me that energy balance or those design loads? Because most of the time the design team typically won't want to hand over the information because you might find something wrong. The owner's role is key. If I go into a room with the design team, it won't work. I need the EED owner with me to say, hang on, this is important. We need to make sure that this will happen. So it's really key that you have an active owner that says a few words every now and again to make sure that this works. And just one final point on this. Merck Sharp and Dome have seen the benefits of this and have taken it from Carlow and integrated it into their global program. So the energy efficient design process is now a standard across all of the MSD developments across the globe. So if they've seen the benefit to it, I hope you'll see the benefit to it too. So that's it from me. Back to Jason.